हो जाएगा start. Hello Charan, how are you? Hi Minal.
Fine,
Hi,
sir.
sir.
Right, what happened? Some issue I think sir told me.
Yes, sir.
Now everything good?
Family emergency, medical emergency. So,
Okay. Now it's good?
yes, sir.
Okay. Right. Just take care. Okay now.
Yes, sir. Thank you, sir.
Okay, so everyone is here. So let's start now. Okay. Okay. Okay, let's just start. So we were in the electromagnetism we have to discuss today. Okay now. So let's just start here. Okay, last thing we discussed was the electric field calculation, isn't it? Using the Gauss law, we have calculated the electric field due to different type of arrangement, isn't it? Like point charge we have calculated, line charge we have calculated, okay? Thin sheet we have calculated, okay now? And hollow and solid sphere, and as well as the hollow and solid cylinder we have calculated, okay? And one example we have taken where the charge density was given variable. So in that case also we have calculated how to find the electric field. Okay. So these were the application of the Gauss law to calculate the electric field due to different type of charge. Okay. Charge distribution. Now let's start with the electric potential energy. Okay. So electric potential energy, whenever we say, what does it mean? That means we are going to discuss about that interaction between the two charge particle, okay, like electric field and electric force, okay. This is a conservative force, isn't it? And whenever there is a conservative force involved, we can define the potential energy of that one, okay. So electric potential energy or electrostatic potential energy means the potential energy between the interaction of two charge particle, okay. So let's say one charge particle is something q1 given, other one q2 given, and these are separated by what? Separated by a distance r. So electric potential energy of this arrangement of charge will be how much? K q1 q2 by r. In force it was what? It was r square proportionality. But in the potential energy what we have? It is r proportionality. It means inversely proportional to r. Okay. So that is the potential energy between the two charge particles. Is that clear? Please tell me, everyone, is that clear?
Yes.
Right. So potential energy can be positive or potential energy can be negative as well, isn't it? Means if two similar type of charge particle are there, then what will happen? Potential energy will come negative. And if two opposite type of charge particle is there, then what will happen? Potential energy will come negative. Understood? So similar charges, okay? Similar charges are given to us. That means both are positive or both are negative. What we will get? Potential energy will be positive in that case. And for opposite charges, okay, for opposite charges, what will happen? The potential energy will be what? It is going to be negative in that case, okay. Now one thing about the potential energy is what? Whenever they will ask in the question, what is the total potential energy of the system, then what we will do it? Then we have to write all the pairs which is going to form. Understood? means interaction between each and every one we have to write it. Is that clear? So if let's say in a situation there are given multiple charges, let's say this is the q1 given, this is q2 given, this is q3 given. Okay, they all have the separation between them. Okay, something r1 r2 r3 like that. So if we write the total potential energy, then what we will write it? Potential energy between 1 and 2, then between 2 and 3, then between 3 and 1, all the pairs completed. So like that we have to follow it. Okay, if three charge particle are given, then we will have how many pairs? Three pairs will form. Two charge particle, so one pair will form. If four charge particles are there, can you tell me how many pairs will form? Please tell me. For four charge particle, how many pair will form? Can you tell me how many pair it is going to form if four charge particles are given in the question? Tell me. So number of pairs, if I want to calculate, that will be NC2. The symbol is known to you? Combination NCR.
Six pairs.
Please tell me.
NC2.
Are you aware about the symbol or not? Yes, yes, NC2.
Yes, sir.
Factorial symbol. Remember? Factorial. Right. So NC2 means what? NC2 means factorial n by factorial 2 into factorial n minus 2. That is the meaning of NC2. Right? Permutation and combination in the mathematics algebra, you will see the symbols used. Okay. The number of pairs means what? Any two charge particle is going to form a pair, isn't it? Any two charge particle is going to form a pair. So if we want to calculate how much is going to be the total number of pairs, then what we can write? We can write NC2 number of pairs is going to be. So that's why if four charge particle is given into question to us, so total number of pairs going to form is 4C2 and 4CT is equal to 6. Okay, so total 6 pair will form. Understood? Please tell me, clear up to this?
Yes.
So this is the number of pairs. Okay. Now let's take an example of calculation of potential energy. Okay. Let's see in this example what is given to us. Taking a simple example only, tell me in this question what is given. There are four charged particles are there. Okay. All four are equal charges. All four are positive only. Okay. They are asking, and these are placed at the corner of the square. Okay, corners of the square. They are asking in the question, find total potential energy. Okay, find total potential energy of the system of charges. Okay, total potential energy of the system of charges. Now they are asking how much it will be. Understood the question?
Yes, sir.
So please tell me how much it is going to be. Total potential energy if we want to write. So first of all, identify the pairs. Okay, na? First objective, whenever you are going to calculate the potential energy, you should identify the number of pair. The 4 is there, so total is going to be 6 pair, isn't it? 4C2. It means in the question I must have, when I will solve, I will have 6 pairs. Okay. See, are these two going to form one pair? This one and this one is going to form another pair. This one and this one another pair. And this one more pair. So can I say that what is the potential energy of that one? K, Q, Q by A. How many pairs
Times
like
4.
that? Are there 4
Or
pairs like that? Next, are there going to be K, Q1, Q2 by root 2a. Diagonally opposite charge particles are also interacting, isn't it? And how many pairs are like that? There are going to be two pairs like that, isn't it? So what happens now? Sometime when the number of charges increases, na, then we may have a chance that we may miss one or two pair like that. Okay. So always before writing the terms, make sure that you have already counted the number of pairs so that when we'll be writing the potential energy, none of the pair will be missed. Okay. Here, if you see this example, it was a square given. Instead of a square, what I am going to give you this time, I am going to give you at the corners of a cube. I am going to give. Okay, what I am going to give you at the corner of the cube given to us. How many corners the cube will have? 1, 2, 3, 4, 5, 6, 7, and 8. Right?
28 pairs.
Hello.
Yes, sir.
Yeah, is it audible?
Yes, sir.
Right. Okay. So let's continue. This is the example I have given that there are 8 charges at the 8 corner of a cube. Okay. And now we have to find out what is going to be the total potential energy of this configuration. So can you tell me how many number of pairs will form first? So that when we will be writing those terms, we will not miss any one of
24 pairs. 28.
28, right? How many number of pairs going to form? Number of pairs is going to be 8C2. That means factorial 8 by factorial 2 into factorial 6. So if you calculate it, how much it will come? 28 number of pairs going to be. So 28 total number of terms we are going to have. Okay. So let's write it in such a way that we should not miss it. And now 28 terms, we are not going to write it, isn't it? So let's write it one by one. See that. One side, two side, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So are there going to be 12 pair having K, Q1, Q2 by A? 12 pair plus. Now look at the diagonals. Face diagonal. These will be called as what? The face diagonal. The total let's see nowadays. I think okay. Let's do that. Okay. Please tell me this question is clear. The total potential energy what we have calculated here. Please tell total or just give me a moment. What I am doing. Just for today, I'm keeping the video off for some time. Okay. Okay. So that even with
Okay,
little
sir.
bit low bandwidth, it will be working. Okay.
Okay, sir.
Right. So this is the total potential energy. We got it for this configuration. Okay. Now understand these questions. So these are the question based on what? The total potential energy calculation. Okay. Now, once we know there is a potential energy due to the charge configuration, then sometime in the question, what they will do, they will ask us to use what? Use the energy conservation. Okay. Why? Because here the forces involved are the conservative forces. So what will happen? If only conservative forces are involved in a question, right? we can apply the mechanical energy conservation, isn't it? Tell me, what is the condition needed for mechanical energy conservation? Mechanical energy. Mechanical energy is also called as the total energy of a system. Okay, mechanical energy, or we can also call it as the total energy of a system. Okay, so when we can apply the mechanical energy conservation? So to apply the mechanical energy conservation, what is the condition needed? Can you tell me what is the condition needed for mechanical energy conservation? If work done by, okay, if work done by non-conservative forces. Okay, non-conservative forces means what? These we will learn it in the work energy chapter, but there will be some questions on the energy conservation here also. So that's why we are discussing here. If work done by non-conservative forces are zero, non-conservative forces means what? The forces whose work done depends on the path. Okay. So if work done by non-conservative forces are zero, then what will happen? Then total mechanical energy, okay, then total mechanical energy of the system, okay, total mechanical energy of the system will be what? Conserved. Will be what? The conserved, right? So if total mechanical energy is conserved, can we say that mechanical energy is conserved means what? Can we say if that condition is satisfied, can we say initial kinetic energy of the system plus initial potential energy of the system, and after some time configuration of the system got changed, then can we say that final kinetic energy of the system plus final potential energy of the system are equal? That means what? That means it is what? The conserved in the question. Understood? So whenever, and that can be only applied, this mechanical energy conservation can be only applied if we see in a question there are no non-conservative forces doing the work. Understood? So in the absence of non-conservative work, we can apply the energy conservation. Okay, like if I ask you a situation, can we take help of an example and try to solve this question? Please tell me. Please tell me, clear up to this? All of you, please tell.
Yes, sir.
Yes, sir.
Right. Other people tell me.
Yes, sir.
Right. Sushant. Okay. Next. Everyone tell me. Clear up to this? Up this one I will discuss with you in detail. Don't worry about it. Okay. Type of energy, when we will conserve it, specifically when we will go to the work energy chapter. But here also some questions will be the application of the energy conservation. Okay. So like let's take an example here. Let's take an example. In the question, what they gave, that there is a particle of charge q and it's a positive charge particle. Its mass is given as m. Okay. And there is another charge particle. Its charge is minus q. And can I take mass different? Because then I will need to apply one more equation, mechanical energy conservation, as well as one more equation I have to apply it. Can I take it a different mass? And both concept can be discussed it together? Okay. Let's take the mass of this one as 2m. Okay. Now what is given? Initially it is given they are very, very far away. Okay. Initially they are very far away. Matlab, very far away, generally we can call it infinite distance away. But but as you see, they are opposite type of charge particle, so they will start attracting towards each other, isn't it? They will start attracting towards each other. So after some time what will happen? Their motion will happen along this line, because that is the line along which they are going to attract each other. So after some time what will happen? Let's say after some time this plus q reached here, and this minus q reached here, and the separation between them has become something r now. Understood the question? Initially, they are very far away, and sometimes they will mention in the question from very far away, two opposite charged particle are uh, released. Released means what? Considering initial kinetic energy as zero. So now they are asking when they are r distance away from each other, then asking what will be their kinetic energy. Okay, matlab each particle kinetic energy will be how much? Please tell me, do you understand the question?
Yes, sir.
The question asks, find velocity of each particle. Okay, find velocity of each particle. Okay, each particle when when separation separation between them is r. Understood? This is what they are asking. First of all, tell me, when they will be r distance away from each other, can I say that m mass has v1 velocity and 2m mass has v2 velocity? Please tell me. Can we say that? When they are r distance from each other, they will have, when they will be r distance from each other, they will have some velocity v1 and v2, right? Now, I am going to write the energy conservation. Okay, first equation. So tell me, what is initial kinetic energy? K initial plus U initial will be equal to K final plus U final. Please tell me, what is initial kinetic energy? All of you, please tell me, what is initial kinetic energy? Is that a zero? Please tell me. Initially, both the particle is just released from very far away distance. So initial kinetic energy of both the particle is going to be zero, right? Next, what is initial potential energy? Is that also zero?
Zero, sir.
Right. Why initial potential energy zero? Because potential energy will be K Q1 Q2 by R. And when they are very far away from each other, R will be very close to infinity, right? That gives us initial potential energy also zero. Now, when they will be r distance away from each other, let's write the kinetic energy and potential energy now. So what is the kinetic energy of m mass? Half m v1 square plus. What is the potential energy of 2m mass? So half 2m into v2 square, right? Now I have written the kinetic energy of these two particles involved in the question. Understood? Now I will write their potential energy. Can you tell me what will be their potential energy? K, Q1 is plus Q, Q2 is minus Q, and distance between them is what? R at this moment, right? So this is the first equation. We call this equation as what? Conservation of mechanical energy. Understood? Short form COME, conservation of mechanical energy. This is what we have applied in the first equation. Understood? Let's simplify this equation a little bit further. Half m v1 square plus half 2m v2 square equal to k q square by r. But if you look at the equation 1, you will say, sir, we have the two unknowns, isn't it? If I look at the equation 1, what I am feeling that there are two unknowns, na? V1 and V2. Please check it. if I look at the equation 1, we have the two unknown, V1 and V2. So that means, do I need one more equation to solve this question completely? Please tell me.
Yes, sir.
Do I need? So please tell me from where I'm going to bring the second equation. Now, look at these two particles. Are they applying exactly equal and opposite force on each other? Are they applying exactly equal and opposite force on each other?
Yes, sir.
So, can I say that net force acting on the system is zero? System means both the particles together as my system. So, net force acting on the system is zero. And what is the outcome of that? If net force acting on the system is zero, can I say their linear momentum will be conserved? Please tell me.
Yes.
If net force acting on a system is zero, can we say the linear momentum of system will be conserved?
Yes.
Linear momentum of system will be what? Conserved. Understood? So I am going to write one more equation. Tell me, what is initial linear momentum? Is that a zero for both the particles? Initially, both were zero velocity. And at a distance r, at this moment, if I'm asking, what is the linear momentum? So m mass v1 momentum positive because of the direction. Linear momentum is a vector quantity. So we have to write with direction plus 2m mass into v2, but that is in the opposite direction. So minus. Understood? So we have our second equation. Can you tell me what is the second equation? Second equation is conservation of linear momentum. Understand? That's why we took this question, so that we will be learning two equation, application of two equation. What are the two equation? One equation is conservation of mechanical energy. Other equation is conservation of linear momentum, right? So if you simplify this equation, am I getting V1 equal to 2V2? Please tell me. Am I getting, after solving the equation 2, are we getting V1 equal to what? 2V2. Now, once we know the V1, V2 relation, we are going to solve our equation further. Now tell me, can we solve the equation 1 now? Please tell me. Equation 2 gives me the relation between V1 and V2. Now I'm going to put those value in our first equation. So half m, what is the V1 we have calculated? V1 we have calculated 2V2 square plus half 2m V2 square equal to kq square by r. If you simplify it, half common, m common, half and m common, so we have 2 square, that means 4v2 square and another 2v2 square. Is it 6v2 square? That should be equal to what? Kq square by r. Understood? So what we got the v2 value? V2 is coming 2 and 6, you can cancel it out. It will become 3. So V2 we are getting as kq square by 3mr under root. Please tell me, are you clear about the V2 calculation? So if we know the V2, we can also answer what will be V1. V1 will be 2 times of V2. So kq square by 3mr, that is the V1 and this is the V2. Please tell me, are you clear about these two things? V1
Yes.
and V2 cal. Please tell me, clear about V1 and V2 calculation?
Yes,
So
sir.
one equation is conservation of mechanical energy and the other equation is conservation of linear momentum. Why did we conserve the mechanical energy? Because we saw in the question there is no work done by any kind of non-conservative forces. That's why we applied the mechanical energy conservation. And the second one, linear momentum conservation. Why? Because we saw there is no net force acting on the system. See, each particle is experiencing the force. You see, you cannot say that, sir, there is no force in the question. No. each particle is experiencing the force, but if I look at together as these two particles, my system, okay na? If I look at together these two particles as my system, then I see there is no force acting. Understood? That's why we conserve the linear momentum of the system, not individual particle. Understood? Acha, what will be velocity of approach? Just a little bit different thing I am asking in the question. What will be velocity of approach? Uh, we have solved up to this. What will be velocity of approach?
The V1 velocity, I think.
Velocity of approach I am asking in the question. Tell me how much it will be. V1 minus of minus V2. Please check it.
Uh,
Velocity of approach means what? With what velocity they are coming towards each other. Understand the question? With what velocity they are coming towards each other. So velocity of approach is nothing but their relative velocity. Understood? What is the velocity of approach? Velocity of approach has another name. Actually, this is the same thing as the relative velocity.
then
Okay? Relative velocity of these two particles. Clear? Relative velocity of these two particles. Is that clear? So is it going to be V1 minus V2 vector? है ना? V1 minus V2 vector. And look at the direction of V1 and V2. They are opposite of each other, isn't it? Opposite of each other. So when you will put the value, what you will put? V2 value, you will keep it 2k q square by 3mr. You have taken this as positive. So minus V2, what you will take it then? Then V2 you will take it minus. है ना? How much is that? K q square by 3mr. Then what we are going to get our answer? 3 times of under root of k q square by 3mr. That is our velocity of approach in the question. Understood? Please shall understand everything about this question. Energy conservation. How do we relate the potential energy of the charged particle system?
Yes, sir.
Right. So now let's do one last example on this one. Okay. This is also a similar example. What we discussed here. In this example, what is given? See, the example gave here on the x-axis. Okay, this is x-axis and this is the y-axis given to us in the question. Okay, these are the x-axis and y-axis given to us in the question. Question gave on the x-axis there is a plus capital Q charge and there is another plus capital Q charge. Okay, these two are equidistant from each other. Matlab that distance is also a and that distance is also what? A. Question gave there is a small charge particle here. Its charge is Q and mass is what? M. Sorry, charge is minus Q and mass is what? M. Understood? What is this word? Its charge is minus Q and the mass is what? M. And it is projected along y-axis. है ना? Projected along which direction? Along y-axis with some velocity v. So can you tell me what will happen? Can you tell me what will happen? See, you have given some velocity initially, but as it will move further, what will happen? Its velocity will reduce, no? Why it will reduce? Let's say after reaching somewhere here, what will happen? Is it going to be attracted by this two charge particle? Is the minus q charge particle is actually attracted. Matlab it will deaccelerate. Deaccelerate means what? It will finally come to rest at some point na, on the y-axis and then again it will be what? Pulled back. Please tell me, is it this kind of motion it is going to follow? Please tell me. With the two charge particle plus q given like that, what we did? We gave some velocity through a charge particle minus q mass m. So now what will happen? This charge particle will move some distance on the y-axis, and after moving some distance, what will happen? It will come to rest momentarily, and after coming to rest, what will happen? Will it stay at a rest at that point? No, it will pulled back again. है ना? So we have to find out in the question what is the maximum distance traveled by. Understand the question? My question is find maximum distance. Okay, find maximum distance traveled by charge particle. Okay, traveled by charge particle along what? Along the y-axis. Understand the question? Along y-axis before momentarily coming to rest. Momentarily coming to rest. Okay, after that again it will be pulled back, है ना? So how much it maximum traveled before coming to rest? Understood? This distance I have to calculate it in the question. Or sometimes they'll say what is the maximum y coordinate? Please tell me what we should do it in this question. What we should do it in the question. Should we again apply the energy conservation in this question also? Please tell me. Should we apply again energy conservation in this question also? Because the force acting on the charge particle is only conservative in nature. Understood?
Yes, sir.
So let me think that it has moved some L distance before coming to rest. Okay, how much it moved? It moved L distance, and after reaching this L distance, what happened? Its velocity becomes 0. So that L I have to calculate it in the question. Please tell me what I should do it. So to solve this question, I am going to apply this energy conservation one more time. Okay. So what I am going to do it in this energy conservation equation, I will write it K initial plus U initial equal to K final plus U final. Tell me what is K initial? And these two plus Q, na, capital Q, these are fixed. Okay. These two charge particle are what? These are the fixed charge particle that is given in the question. These two charge particle are what? The fixed one. So please tell me what is the initial kinetic energy of this particle? Is it half mv square? Please tell. What is the initial kinetic energy of the particle? Is it half mv square plus what is potential energy? Is the potential energy is k q minus q by a into 2. Please check it and tell. K capital Q minus a small q by a. Isn't it between the negative x-axis charge particle and the q minus q one potential energy, and between another positive x-axis plus q and the minus q another potential energy? So is it the initial potential energy is written? You will be
Yes.
saying, sir, let's write one more term, but that term is not needed. Even if you forget about that term, your calculation will come same. Do you know what is this one? KQQ by 2A? Between those two fixed charges. Understood?
That is.
So did I write all the terms properly? Matlab K initial and U initial. Did I write properly? Now I will go to K final and U final. What is the final kinetic energy? Initial means this point is my initial point. Okay. And where it comes to rest momentarily, that is my final point. So tell me, finally, what will be the kinetic energy? It came to rest now, so 0, right or not? It came to rest, so potential and kinetic energy 0. What is the potential energy now? So K capital Q minus q divided by. Can you tell me what is this distance? Can you see what distance I am talking? This distance. What will be this distance?
2 to
Is the
L
distance? Yes, under root of a square plus L square. And like that, do I have the two pair again? Same, na? Other charge particle will also create the same potential energy, isn't it? Plus K capital Q by 2A. So do you see that in the calculation, these two terms are same, that got cancelled out. That's why I said even if you forget this term, still your answer is not going to get affected. Understood? But whenever we are writing something, we must write it with the proper process. Okay, na? So please tell me now, will I get this one? Half mv square this side. Let's send the other side everything. Okay. So what will come? K capital Q minus Q by A into 2, right? And I have sent it other side. Minus K capital Q small q 2 divided by under root of A square plus L square. So if we simplify a little bit, we will get our answer. So half mv square. Let's take common 2 capital K small k and 2 capital. Here, if I take something common right hand side, 2k capital Q small q, a we have taken common. What we have here? Minus 1 and please check it. I think this one will become positive na? After sending the other side. If we send it other side, it will become what? Positive, na? Right? So 2k capital Q small q by a common 1 minus 1 minus 1 by under root of a square plus L square, right? This is what we have. Please tell, are you clear about this equation?
Yes, sir.
Yes, sir.
So in the question, what will happen? Values will be given. If the values are given, we will be able to get the total. Means further simplification we can do it. So here we will keep it here just to make you understand about how we are going to apply the energy conservation. We took these two examples. Okay, please tell me, clear up to this?
Yes, sir. Are we going to get the same questions? I mean, these types of question in exam also.
Yeah, sure. But in exam, you will get the question. The numbers will be given to you. Like mass is 0.5 kg, right? Charge is 2 coulomb, or another charge particle is minus 1 coulomb. So like that, values will be given. Understand? In the exam, the questions are having the values mostly given.
I mean, sir, the same level. I mean, uh,
No, it will be means actually what I am trying to do. I am discussing a little bit basic question and as well as little bit harder also. Honestly, if I'm saying, okay, so that if you practice these type of questions, when you will face these questions in the exam, you will feel it is easier, isn't it? It's better to practice hard question at home rather than directly facing in the exam.
yes, sir. Yes, sir. So for practice, did you give any worksheet?
I will prepare one sheet for the electrostatic part and I will give it just by tomorrow. I will try to give it. Okay, tomorrow Sunday is there, so I will try to give this tomorrow for practice. Okay, till then you can practice the questions from the Singh's book. Okay, everyone is solving the questions from Singh's or not? Please tell me. Are you
Solving, sir.
practicing the questions from Singh's or
Yes,
not?
sir. Yes, sir.
Right? So solve the questions from the Singh's. Okay, that is having lot of questions. Okay, na, as per the level you need. For that level, there are many questions in the Singh's. Okay, so you solve that one and separate worksheet. I will give it to you. Okay. so that you can have the additional practice of the questions. Okay.
Yes, sir.
Right. So let's discuss one more thing here. Now you see we have written the potential energy, isn't it? So you see, whenever we are writing the potential energy, we have to write every time about the pair, na? We have to every time we have to write about the pair of charges. So what we did, we made a convenient term called what? Electric potential. Electric what? Potential, or it's also called as the electrostatic potential. Wherever I am using the word electric, its meaning is same as the electrostatic. Okay. What is electric potential? You see, let's say I have a plus q charge here, right? And there is a small charge here. There is a separation between them is something r. This charge is something q naught. So can you tell me what will be the potential energy between them? K, Q, Q naught by R can be written. What will be potential energy between them? The potential energy between these two charge particle is going to be K, Q, Q naught by R will be there. Right or not? Please tell me. This is how we are calculating from the starting only. Right now? So what is the potential actually? If I calculate potential energy per unit charge, means if I take this as a unit positive test charge also it is called as, है ना? This is also called as a unit positive test charge. Means if I take the Q naught as magnitude wise unit and nature wise as positive, then whatever the potential energy will be for this unit positive test charge configuration, tell me what we are going to call that. That is actually called V. V is the potential of that point. Understood? You see, are we following exact same sequence? First, we calculated what is the force between two charge particles. Then we calculated force per unit
Yes,
charge,
sir.
and it became what? Electric field, right or not? See that? First we calculated the force between two charge particles, and the moment we calculated force per unit charge, that becomes the electric field. The same thing, first we calculated potential energy between the two charge particles, and the moment we calculate potential energy per unit charge particle, that becomes the potential of that point. Understood? So what is the potential due to a point charge? Can we say that if I want to write due to point charge, due to a point charge, what is the potential? Will it be equal to K Q by R? Understood? So K is the Coulomb's constant here, Q is the charge particle charge, and R is what? R is the distance at which we want to calculate the potential. Understood? So if it is a positive charge, what kind of potential it will create at a distance r? Can you tell me what will be potential here? So here, if let's say this positive charge is q and I want to calculate at a distance r, this point P is there. Can you tell me what will be the potential at point P? It will be K Q by R. So a positive charge creates what? Positive potential. And if in the other example, if I take a negative charge particle, if I take a negative charge particle Q and I want to calculate potential at this point P, or let's say this point P potential, this is something R dash is given to us, this is Q dash given to us. So what will be potential at point P now? So K, it's a negative charge particle, na? So minus Q dash by what? R dash. So the potential can be positive or it can be negative depending on what? Depending on what type of charge particle is creating the potential. Understood? If it is a potential created by positive charge particle, positive potential will come. If it is created by negative charge particle, the negative potential will come. Understood? So potential can be positive as well as what? Negative. But it is what kind of quantity? A scalar or a vector? If I ask you this question, electric potential is what kind of quantity? Is it going to be a scalar or vector? Scalar, isn't it? Because it is potential energy per unit charge. Potential energy itself is what kind of quantity? It's a scalar quantity. Understood? Energy, na? Energy is a scalar quantity. So please tell me what we discussed till now. Do you understand?
Yes, sir.
So this is what we discussed. Okay. Understood now?
Yes, sir.
Please. Right. So let's meet it tomorrow, 9. Okay. And can we keep it tomorrow 2-hour class? If all of you are free, please tell me. 9 to 11.
Okay, sir.
Okay, we'll check it. Okay, I will check it with all of you. If all of you agree, we will have it the 2-hour class tomorrow. Otherwise, 9 to 10 only. Okay, because yesterday we missed one class. Okay, na? So that's why I'm saying. Okay,
Okay, sir.
right. Let's meet it tomorrow, 9 in the morning.
Okay, sir.
Right. Take care, everyone, and let's meet it tomorrow.